Welcome to Brain Vision.
In this example, we will be trying to determine the pressure of some evaporated water in a container that has a volume of 0.03 meters cubed. The water vapor has a temperature of 388 degrees Kelvin and has a mass of 4 grams. So to do this, we're just going to use the ideal gas law, which is PV equals nRT. However, this form of the ideal gas law is in terms of moles of gas, N, right here. So since we have mass M, we're going to convert this equation into terms of mass M in grams. So to do that, we need to remember that we can convert between moles and mass by remembering that the mass is equal to the number of moles times the molar mass, big M. Or if we solve this equation for little n, the number of moles is equal to the total mass over the molar mass. So we can just plug this in to our ideal gas law here. And then it's in terms of the mass in grams. All right, so if we plug that in, we'll have PV equals little m over big M times RT. And then we just want to solve this for pressure, since that's what we're trying to solve for over here. So to solve for pressure, we'll just divide both sides of this equation by V. And we'll have mRT over big M times V. So now we're ready to calculate. Let's make sure all our units are good to go. Our temperature is in Kelvin. R is just the gas constant, which is in joules per mole Kelvin. V is in meters cubed, which is good to go. M is in grams, which might be okay depending on what molar mass we use. So let's go look up the molar mass for water vapor, which the value I will be using here that I found is 18.02 grams per mole. So we can go ahead and keep this in grams because the grams in the molar mass will cancel out with the grams in our mass here. So if we plug all of that stuff into our equation, we will get that the pressure is equal to 2.39 times 10 to the 4th pascals. So there you have it. We just determined the pressure of a sample of water vapor in a container with volume 0.03 meters cubed, where the mass of the water is 4 grams and the temperature is 388 Kelvin.